Welcome back to our next step. Now before you continue with this video, I want you to go ahead and pause it, and I want you to practice drawing your refrigeration cycle. Practice drawing it and then refer back to one of the ones you've already gotten to make sure you have that down first. There's no sense in moving on yet until we make sure we got that foundation. So pause it now. So hopefully you got that done, and hopefully you did it in color as well. So we learned about evaporation and condensing. We're going to add that to our map we already have. So we have our compressor vapor pump, sucks low pressure vapor, pumps high pressure vapor, moves the refrigerant. That's our compressor here. Then we have our discharge line, also the hot gas line, high temperature, high pressure, superheated vapor. That's this line right here. Then we end up in our condensing coil. So all of this is our condensing coil. That's what we're going to talk about first. What we're going to do now is modify what you've already drawn, and we're going to add in a circle, not the entire condensing unit. A little bit from the top, a little bit from the bottom. We're going to add a circle. I'm going to put mine in a little bit of dots like so. Notice I have a gap here and I have a gap here. What this is going to be called is saturation. We're going to do that next in a short video. Saturation. We're going to write saturation. Saturation. And we're going to write in the middle is condensing. This is where the refrigerant is condensing. So I'm going to write condensing. And condensing means the refrigerant is changing state. So we're going to add that to this, changing state. Changing state from a vapor to a liquid. And because it's changing state from a vapor to a liquid, it's rejecting or giving up heat. That's latent heat. So if we look at this in the middle of the condensing coil, so the middle section of this condensing coil all the way around approximately is where we're condensing. We're changing state from a vapor to a liquid. So right here at the very top of this line, it's approximately, it's right about here, we're going to put 100% vapor. And then here in the middle, let's put 50 vapor, 50 liquid. 50% vapor. And up here, we're going to put 50% liquid. It's about half vapor and half liquid. Now here at the very, very bottom, we're going to put over here that it is 100% liquid refrigerant. So we change state from a vapor to a liquid through the condensing coil. Now we still got some more stuff to add, but now we have this liquid line because the refrigerant changed state from that vapor back to a liquid. That's where all of our heat, we're still rejecting heat here, we're still rejecting heat here, but this is latent heat. It's the massive amount of B2s that we're rejecting. We're rejecting tons and tons of heat out of that refrigerant. It's condensing, it's squeezing it in, it's squeezing all that heat out of that refrigerant. Now we follow through our liquid line filter dryer. And then we end up with our metering device, also known as an expansion device. Whichever one you have to picture, whether it's a metering device or expansion device, it is going to allow it to restrict from a high pressure liquid over here to a low pressure saturated mixture. And blue represents low pressure. So here it's a low pressure saturated mixture. It's 75% liquid, 25% vapor. So we're going to draw another circle, but this circle, it's important. The circle starts from the metering device. Over here we have liquid and vapor. We'll talk about this shortly. But we're going to put a little dotted line circle through most of this evaporator. So what's happening in the evaporator right here is evaporation, also boiling. We're going to put both words in because it's important for us to have that concept down. So we're going to write right here evaporation. We're also going to write boiling. And then we're going to continue on to the definition. Changing state. The refrigerant is changing state from a liquid to a vapor. And that's absorbing heat. Massive amounts of heat. That's latent heat. It's absorbing heat, latent heat. And this is also going to be saturation, so we're going to write saturation here. And then we're going to write saturation along this dotted line. all of this is going to be saturation. So here it's 75% liquid, 25% vapor. Over here at the very top of this line, we're going to put here 100% vapor. So now that we've added what we've learned already with evaporation, changing state from a liquid to vapor, the refrigerant's literally boiling inside these pipes. It's a cooling effect. It's absorbing the heat out of the air into the refrigerant. It's hidden in the refrigerant. It's a low pressure vapor. It's hidden, but it's still there. On this side, we get over here and we're rejecting heat out of the condenser. We're forcing that heat out. We're changing state from a vapor back into a liquid. It's rejecting massive amounts of hidden heat, and it feels warm here because it's a warming effect. Cooling effect, it feels cool. Warming effect, it feels warm. So we're moving heat from a place that we don't want it to someplace else. We're moving heat. And if we see, this is very important because the refrigerant came in as liquid and vapor, but by the time it left, it was 100% vapor. That's very important because this is a vapor pump. So it sucks to the suction line, which is also a gas line. So we'll call it a vapor line. It's also correct, a vapor line, low pressure, low temperature, superheated vapor, and then discharge line, high temperature, high pressure, superheated vapor, condensing in the majority of this coil. We then have a liquid line. Notice the liquid is far away from that compressor. That's very important. Our whole cycle happens again. We're going to put our gauges up here, and if we see on the gauges, low pressure comes into the compressor, high pressure comes out of the compressor. On this side, we have the opposite. High pressure comes into the metering device, low pressure comes out of the metering device. This is where we kind of have our teammates. The compressor and the metering device work together. It's very important. So the compressor is building high pressure against this restriction, against this metering device. The metering device is allowing that pressure drop, and the compressor is pulling it back. So they're working together to create high pressure on this side and to create low pressure on this side. Now, there's a few variances in it, but typically our pressure anywhere here, if I was to put a port anywhere on the red side, it's going to be pretty close to the same pressure. If I put a port anywhere on the suction side, it's pretty close to the same exact pressure. So we got essentially two pressures in this whole system, which is why we have our gauge set, which is going to have simply two pressures. Now, the other thing that works together as a team is our evaporator coil and our condensing coil. But like the compressor and the metering device, they're opposite of each other. So over here, we're boiling and evaporating. Over here, we're condensing. Inside the house, we're changing state from a liquid to a vapor. Outside, we're changing state from a vapor back to a liquid. Inside, we're absorbing heat. That's latent heat of evaporation. Outside, we're rejecting heat. That's latent heat of condensing. Over here, it's low pressure in blue. Out here is high pressure in red. So they are the opposites. They're doing the opposite things. But when we absorb that heat in, we have to also be able to reject the heat out. So they are teammates that do the opposite of each other. So this is our refrigeration cycle. But hold on. We still have more stuff to learn. We got more little bits of information we're going to add in to this system.